All right, so this is the inequality portion. Okay, we also talked about absolute equalities in equations. So hopefully you will see another video from me eventually about that. But right now we're just going to talk about inequalities. If you remember the little booklet we had, we talked a lot about and or. So it's probably a good idea for you to go ahead and label all of your equations before we start. And once you have that done, this should be a little bit easier. Just remember there were two, you start doing two things. So I have x minus 2 greater than 5, and x minus 2, the negative side, greater than 5. I get x greater than 3, and when I do this and divide by negative 2, if I check this out on my number line, I think we have an or statement. So that would be this. So my answer here is an or statement, and it's good. Should maybe try writing these in different colors. This should be an and statement. Right away I look at this and I think to myself, if you don't see it, I'm looking right at this and I'm thinking, can whatever I put in here ever give me anything less than a negative number? This is a no solution. If you decided to solve and come up with a solution, which you could, and you checked it, you would find that it didn't work. So for example, if I just did one side of this, add 4 and I get negative 8, and then I get x less than negative 8 thirds. If I picked x less than negative 8 thirds, like negative 9 thirds, an example that I could choose, try x equals negative 3. I'd get negative 9 minus 4 is negative 12, and then I take the absolute value and I get a positive number. A positive number will never be less than a negative number, so nothing works on this one. When you come across one like this, you need to remember the first step is to isolate the absolute value, and after you do that, now you can do your two pieces. This gets everyone tripped up. We need to subtract 5. Negative 4x less than negative 1. And then I'm going to divide by negative 4. When I divide by a negative number, it flips. X greater than 1/4. When I work this the other way, I get 5 minus 4x less than 4 greater than negative 4. Negative 4x greater than negative 9. And when I divide by negative, I flip again. X is less than 9/4. So if I graph this one, 9/4 would be up here. It looks like I did okay because I did get an and statement. So I would write this like this would be my final answer. All right, let's see another color I can use here. This should be an or statement. First I need to negative 3. And now I can go ahead and do my two different 2x greater than or equal to negative 8x greater than or equal to negative 4. And on the other side, I would have negative 2x plus 5. When I divide, I flip it. Negative 2 and x less than or equal to negative 1. So I'm going to draw this on my number line. So I want all the x's this way, less than or equal to -1, but I want all the x's this way too. And notice when I have these overlaps in an or, that stands for all of these. This one should be all answers. But when you look back at this, 2x plus 5 absolute value greater than -3, won't any number I put in give me an answer greater than or equal to -3 because it's a negative number? So you may have seen that right away. The answer number 4 is all real numbers. Number 5, I need to divide by 3 first and get 6. This should be an or. I just need to remember that. So now I have 2x greater than 6. X is greater than 3. And then negative 2x. 2x, when I divide, flip the sign. X is less than 3. Well, let's see. I forgot to change this to negative, so that'll also be negative. That'll change my answer, and then I feel better about it because I have these here and these here, so that works. I'm going to write my answer up here. X is greater than 3 or x is less than -3. Number 6 is also an or. Hopefully, again, you're looking at this and you're thinking, all right, are there any numbers that I can put in that would be less than 0? I can't get a number less than 0. All my answers should work. So I have x minus 4 greater than or equal to 0. X is greater than or equal to 4. Okay, what if I do the other way? Negative x minus 0. Well, if I divide by negative, I flip it. 0 stays the same. Okay, this should be an or. These both end up as 4. I want all the numbers greater than or all the numbers less than. Turns out the answer for this one is all real numbers as well. This one looks really similar, but the big difference is I don't have equal to. So x less than 4 greater than 0. X is greater than 4. The same thing is going to happen over here when I divide. I flip my sign. The only number that doesn't work is 4. So one way to write this would be x's are all real numbers except 4, or x cannot equal 4. That's the only, if I plug in 4, I get 0. That's the only one that doesn't work. 8, I need to add 6. Isolate the absolute value first. And let's see, 15. And then go ahead and do your two sides. $11, not 9. And then negative. And I'm going to divide by a negative number, so my sign switches. X is greater than negative 19. And is this an and statement? It looks like it. Here's negative 19. Here's 11. And I want all these in between it, less than. So my answer for this one, I'm going to write it up here in this maroon color. X is greater than negative 19, but less than 11. This is my and statement answer for number 8. Again, isolate first. And now you can do the two sides of your equation. 2x minus 1 greater than or equal to 4. X greater than or equal to 3/2. That's okay. Negative 2x minus 1. Flip the sign when I divide. 2x. This should be 5. I just realized my mistake here. because this will be -3 and x will be less than or equal to -3/2. This should be an or statement. Let's check it out. I want greater than and less than. Good. So my or statement holds for this one. Isolate first. Hopefully right here you notice there is no way whatsoever that I can get any number less than -3. This one's a no solution right away. Isolate and I get -4. This is a similar one to this one I did up here in blue. Every number that I get will give me an answer greater than or equal to -4. Any number will work in this situation because I want to be greater than a negative number, and every time I do an absolute value, I will get a positive number. I have to erase this right here. All right, so this isn't one where you isolate. Okay, so 3x minus 1, and this should be an and problem, is less than or equal to 12. I'm going to divide by 3, so x minus 1 less than or equal to 4. Add 1, x less than or equal to 5. Now my other side, now I'm going to divide. Get -12, divide by 3. Add 1. Let's check it out. I want greater than -3, less than 5. I did an and statement, so my answer would look like this. Okay, that is the solving with one variable inequalities. When you have an x and a y, you are solving in 2 variables. So you need to make a table. If you remember where the vertex is, in this case, it'll be 2, 5. So I'm going to just 1, 2, 3, 4, 5. And I'm going to put that right in the middle of my table. And now I'm going to choose numbers less than 2 and numbers more than 2, and I'm going to try them out. When I plug in 0, I get 7. When I plug in 1, I get 6. When I plug in 3, I get 6. 4, I get 7. That's good. This means I have a solid line. So get your dots, use your ruler. Okay. The last step is to test a point. I'm going to test 0, 0. When I plug in 0, I get 7. Is 0 greater than 7? No. So I'm going to shade not where 0, 0 is. That would be the inside here. Okay. Next one. The 4 on the outside has nothing to do with my vertex. So my vertex is 0, -1. That helps a lot of us make our table. Again, you could continue with your table no matter what. You can guess and check points. That's okay. I plug in -2, I get 7, I get 3, 3, and 7 again. So -2, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 3, 7. This should be a dotted line. You're going to use a ruler and make it look better than mine. Last step is to test. So I'm going to test 0, 0. Is 0 less than -1? It is not. So I'm going to shade on the outside. Okay, this one should be a nice upside down. Go away. This one should be an upside down V because of that negative. My vertex will be at 4, negative 2. Put that in the middle here. 2. Pick some points around it. When I plug in 3, 3 minus 4 is negative 1. Absolute value is positive 1. I'm going to make it negative. I get negative 3. The same should happen for 5. When I plug in 2, I get negative 2, turns positive, then negative. Get negative 4 for both of these. So 2, 1, 2, 3, 4. 3, 1, 2, 3. 1, 2, 3, 4, 2. Now we turn back around. This means we have a dotted line. Okay, and then the last step is to test 0, 0. 0 greater than, what do I get here? Negative 6. Yes, 0 is greater than negative 6. So I would shade above. Some more here. My vertex on this one will be 0, negative 7. Okay, I'm going to pick some points around it. Plug in negative 2, I get 4 minus 7 is negative 3. 2 minus 7 is negative 5. All right, so my vertex worked. Negative 2, negative 3, negative 1, negative 5, 7, 5, and 3. Then this means solid line. I'm going to test 0, 0. Is 0 less than or equal to negative 7? No, it is not. So I'm going to shade opposite, not where 0, 0 is. 17 is super tricky. First, I'm going to divide by negative 1. And what happens when I divide by negative 1? The sign switches. Subtract negative 1. I'm going to write it up here so I have more room. Y less than or equal to negative x plus 4 minus 1. Okay, so this is what I'm graphing. It should be upside down. My vertex is at negative 4, negative 1. Negative 3. If I plug in negative 3 to this one up here, I get 1, turn it negative, negative 1, minus 1 is negative 2. Same with 5. You should plug in a few more points. And this should be upside down. And a solid line based on this here. And then we're going to test 0, 0. If I plug in 0, is that going to be less than or equal to negative 5? Do that right? Is 0 less than negative 5? Oh, I switched the sign. It should be greater than. Do that, Mrs. Vogt. Oh, no, I did it right. No, it is not. So you're going to shade underneath. I kept looking at my original problem thinking that's my vertex. I found that from here. When I plug in 1, I get negative 3, which is positive 3, negative 3 minus 2. Don't think I did that right. 1 minus 2 is negative 1. So you get negative 3 here. When I plug in 3, I also get negative 3. So 2, negative 2, 3, 1, negative 3. I did that wrong again. Let me see. This should be upside down. So I should get 1 and then negative 4. So that's a good way to check your work. I started making a V and it was right side up, and then I realized, oh, something is wrong. So when I plug in 1, 1 minus 2 is -1. It becomes positive, make it negative again. So I'm doing something wrong because, oh, nope, I had it right and I just couldn't graph correctly because I also had 1, -3, and then I had 3, -3, and apparently I couldn't graph right. This means dotted. Last is to test a point. Is 0 going to be greater than -4? And it is, so I'm going to shade above. Okay. The next few are matching. So this one here is meant to represent all real numbers. And this one here is meant to represent no solution. Okay, and this one is to represent one answer. And then these are two different and solutions here. Hopefully you see that. So I kind of am looking at these and I'm thinking, which one can I eliminate right away? Is there one that I can eliminate? This one, to me, looks like this one's not going to be so bad because I just go x less than or equal to 8 or x greater than or equal to -8. And this is an and problem. So this one matches right here. I'm between 8 and -8. Okay, this one, so hopefully I didn't cut off any of my video. When I add 2, I get x less than 8. And then the other way, x minus 2 is greater than -6, x greater than -4. And this should be an and statement. So this one goes here. So that means what I have left are kind of the weird ones, like all real numbers, no solution, and x equals 1. So just doing this next one, if I divide by 3 first, that should be a -3. I hope that you're saying to yourself right now, anything I put in will become positive. So this is the all real numbers because I can never get, or I will always get an answer greater than or equal to -3. Let's pick a color I haven't done yet. I'm going to divide both sides by -4. So 3x minus 1. I'm going to switch this less than or equal to 2. I switched it because -8 divided by -4 is 2. So now I have 3x minus 1 less than or equal to 2. 3x is less than or equal to, I'm going to add 1, 3, and x less than or equal to 1. And then I'm going to do it the other way, 3x minus 1, 3x greater than or equal to, add 1, -1, x greater than or equal to -1/3. Okay. And this should be an and in the right spot. Hopefully I can edit it. If I work on this one now, right here, I can solve this. And when I solved it, I got the following solutions. I got x less than or equal to -1 and x greater than or equal to, oops, this should be +1, sorry, 1/3. And hopefully you notice that this is an or equation. And the solution that I've come up with here is an and solution, like it would look something like this. And because of that, and this should be negative, this is a no solution, so that's this one here. And then my last one, when I isolate, I should add 3 first. 2x plus 2. And then when you divide by 0, you have, or divide by -5, you do have to flip the sign. And so I hope that you notice right here that this means less than or equal to 0, and I can never be less than 0, so I can really only be equal to 0. This has one solution, x equals 1. Okay, write an inequality that matches these graphs. We talked about finding the vertex. So this vertex is at -1. Again, I'm struggling, which is why I've had to make this a few times, -3, -1. And then some of us have kind of looked at the slope to determine this. And we've made sure that slope is 1 in every situation. So 1, 2, 3, 4, 5 over 1. The slope in this case is going to be 5. So 5. And again, all of ours have been 1 or -1. And then you would test a point. And I know that this is greater than. This is over 1, up 0. And my slope is 3. So y less than or equal to 3x minus 1 plus 0. This one will be negative. And then a in this case will be 1/2. So y is less than -1/2 x. So where did I go? Plus 2 plus 1 minus 2 plus 1. Give a solution and a non-solution. Basically, can you find a point in and out? So like in this case, a non-solution is 0, 0. 0, 0 works for this one. 0, 0 does not work for this one because 0, 0 falls on the dotted line. So you would have to pick a different point, but any point for a solution would be within the shaded region.